Download this code from codegive.com, link in the description below. Server-side request forgery, SSRF, a detailed tutorial with real-world examples and code. Server-side request forgery, SSRF, is a web security vulnerability that allows an attacker to make requests from the server hosting the application to unintended destinations. This could be internal services, other servers within the infrastructure, or even external websites. SSRF attacks leverage the server's trust in itself and its internal network to bypass security controls and access sensitive data or functionality. This tutorial will delve deep into SSRF, providing real-world examples, code snippets in different languages, Python, PHP, and mitigation strategies. 1. Understanding the core concept. Imagine a web application that allows users to upload images or import content from external URLs. The server receives a user-supplied URL, fetches the content, and displays it. Now, instead of providing a URL to a legitimate image or content file, an attacker supplies a URL to an internal service, a database, or even a loopback address, 127.0.0.1 or localhost. The server, unwittingly, executes this request on behalf of the attacker. Why is this dangerous? Access to internal services. The attacker can access internal services, example databases, administrative panels, that are normally not exposed to the internet. These services often lack proper authentication because they are behind firewalls and considered trusted. Reading local files. The attacker can read local files on the server, potentially including configuration files, source code, and even sensitive data like API keys or database credentials. Port scanning. The attacker can scan the internal network to discover other services and their open ports. This helps them build a map of the internal infrastructure. Arbitrary code execution. In some cases, if the attacker can find an internal service with a vulnerability, they might be able to execute arbitrary code on the server. Bypassing access control lists, ACLs, and firewalls. The server is already inside the firewall, so requests originating from it are often trusted, allowing the attacker to bypass security measures. Denial of service. The attacker can cause the server to make a large number of requests to a specific target, potentially overwhelming the target and causing a denial of service. 2. Real-world examples and scenarios. Let's look at some realistic scenarios where SSRF can manifest. Image upload / import feature. Description. A website allows users to upload images from a URL. The server downloads the image from the provided URL and displays it. Vulnerability. An attacker could supply a URL like http://127.0.0.1/admin or file // etc. /password. The server would then fetch the contents of the admin panel or the etc. /password file. Code example, Python, Flask. How to exploit. Submit a URL like http://127.0.0.1:8000, assuming a web server is running on the same host on port 8000, or file // etc. /password. You might see the contents of that local server's root page, or the system's password file. Warning: do not attempt to read sensitive files on systems you do not own or have explicit permission to test. Webhook integration. Description. An application integrates with webhooks. When a specific event occurs, the application sends a request to a user-configured URL. Asterisk vulnerability asterisk an attacker could provide a URL pointing to an internal service or even a reverse shell server they control. Asterisk code example, PHP. Asterisk how to exploit asterisk set the webhook _URL to something like http://localhost 3306, assuming a MySQL database server is running on the same host. The server will attempt to connect to the MySQL server, likely resulting in an error message revealing information about the internal database. A more advanced attacker could try to interact with the MySQL server using specially crafted requests if the curl configuration allows it. Asterisk URL shortener asterisk. Asterisk description asterisk a URL shortener service retrieves the title and description of the original URL to display a preview. Asterisk vulnerability asterisk an attacker could supply a URL pointing to an internal service. Asterisk server-side template injection, SSTI, plus SSRF asterisk. Asterisk description asterisk the application uses a server-side template engine, example Jinjia 2, Twig, FreeMarketer, that is vulnerable to SSTI. SSTI allows an attacker to inject code into the template and execute it on the server. Asterisk vulnerability asterisk the attacker uses SSTI to trigger a request to an internal service. Asterisk example, Python, Jinjia 2. Asterisk how to exploit asterisk an attacker can inject Jinjia 2 template code to perform SSRF. For example, submitting a template like URL_for, URL equals http://127.0.0.1, assuming you define a custom Jinjia 2 filter or use an existing one to make external requests, could trigger the application to make a request to localhost. SSTI exploits are complex and require understanding the specific template engine used. Many payloads can be found online. Warning: SSTI is extremely dangerous and can lead to remote code execution, RCE. 3. Exploitation techniques. Asterisk basic SSRF asterisk the attacker provides a URL to an internal resource, example http://127.0.0.1:8080/admin. Asterisk bypassing whitelists asterisk. Asterisk URL encoding asterisk encode parts of the URL to bypass simple string matching whitelists, example http://31%, 32%, 37%, 30%, 30%, 31. Host name variations use different host name variations, like localhost, 127.0.0.1, 0.0.0.0, :1, IPv6 localhost, or 127.1. DNS resolution issues some servers might resolve host names differently. You could try using a public DNS server that resolves a host name to a local IP address or vice versa. Mixed case try using mixed case host names, example localhost. Adding a trailing dot some parsers may treat localhost as still resolving to localhost. Using an IP address that resolves to loopback find other IP addresses on the 127.0.0.0/8 range that resolve to the loopback interface, example 127.0.1.1. Bypassing blacklists redirection use a URL shortener or a 302 redirect to hide the final destination URL from the server-side check. Embedded credentials in URLs while generally discouraged, some older systems might still be vulnerable to passing credentials in the URL, example http://user_password@internal.example.com. Never actually use this method with real credentials. File protocol use the file // protocol to read local files. Gopher protocol, less common, but still possible. The Gopher // protocol allows you to send raw TCP commands to a server. This can be used to interact with services like SMTP or databases. It's less common now as many servers block Gopher due to its security implications. Bypassing validation with special characters **@, symbol **. Some URL parsers might interpret the part before the @ symbol as user credentials and ignore it, potentially bypassing validation. For example, http://evil.com at 127.0.0.1. The server might try to connect to 127.0.0.1. *#, symbol **. The part after the symbol is typically treated as a fragment identifier and is not sent to the server. You might be able to use it to bypass validation. http://legitimate.com at 127.0.0.1. 4. Mitigation strategies, hardening your application. Preventing SSRF requires a multi-layered approach. Here's a comprehensive list of mitigation techniques. Input validation and sanitization strict whitelisting allow only specific, known good URLs or host names. This is the most effective defense if you can identify all legitimate destinations. If possible, whitelist by IP address rather than host name to avoid DNS-related bypasses. URL parsing and validation carefully parse the URL using a robust URL parsing library, example erlib.parse in Python, parse_URL, in PHP. Validate the scheme, example HTTP, HTTPS, hostname/IP address, and path. Regular expression validation if whitelisting is not feasible, use regular expressions to validate the URL format and ensure it conforms to expected patterns. Be very careful with your regex to avoid bypasses. Canonicalization convert the URL to its canonical form, example remove redundant slashes, decode URL encoded characters, before validation to prevent bypasses using URL manipulation. Reject reserved IP addresses explicitly block requests to reserved IP addresses, including loopback addresses, 127.0.0.0/8, IPv4:1, IPv6. Private IP ranges, 10.0.0.0/8, 172.16.0.0/12, 192.168.0.0/16. Link local addresses, 169.254.0.0/16. Multicast addresses, 224.0.0.0/4. Network segmentation isolate sensitive services place internal services and databases behind firewalls and restrict access to them. Only allow authorized servers to communicate with these services. Principle of least privilege grant only the necessary network access to each server. If a server doesn't need to communicate with a database, don't allow it. Disable unnecessary protocols disable or block unnecessary protocols disable or block protocols like file // gopher // ftp // data // etc., unless absolutely necessary. These protocols can be abused to read local files or interact with internal services. Use HTTP proxies or firewalls Web Application Firewall, WAF use a WAF to detect and block malicious requests. Configure the WAF to block requests to internal IP addresses or suspicious URLs. *forward proxy * route all outgoing requests through a forward proxy. The proxy can enforce policies, log requests, and prevent access to unauthorized destinations. *authentication and authorization *. Authentication for internal services * implements strong authentication for all internal services, even if they are behind a firewall. Don't rely solely on network segmentation for security. Authorization checks * verify that the user or application making the request has the necessary permissions to access the requested resource. Timeouts set timeouts for HTTP requests set reasonable timeouts for all HTTP requests to prevent the server from hanging indefinitely when trying to connect to a non-existent or unresponsive service. Error handling sanitize error messages avoid leaking sensitive information in error messages. Instead of displaying the full error message to the user, log the error internally and display a generic error message to the user. Code review and security audits regular code reviews conduct regular code reviews to identify potential SSRF vulnerabilities. Penetration testing engage a penetration tester to test your application for SSRF and other security vulnerabilities. Centralized configuration and management configuration management use a centralized configuration management system to ensure that all servers are configured securely and consistently. Regular security updates keep all software and libraries up to date with the latest security patches. DNS resolution prevent DNS rebinding DNS rebinding allows an attacker to bypass SSRF protections by initially resolving a domain to a public IP address, passing the initial validation, and then changing the DNS record to point to an internal IP address. Implement mitigations like double check IP address after the initial DNS resolution, re-resolve the host name and verify that the IP address hasn't changed. Use a fixed resolver configure your application to use a specific DNS resolver to prevent attackers from manipulating DNS records. 5. Code examples, mitigation. Here are the code examples from before, now with mitigations. Image upload / import feature, Python, Flask mitigated. Webhook integration, PHP mitigated. Key improvements in the mitigated examples One is _valid _URL, function *a dedicated function is used to validate URLs. This keeps the main application logic cleaner. 2 regex-based URL format validation *a basic regex checks that the URL starts with http / or https //. This regex should be significantly improved in a real-world application. It's just a starting point. A good regex would be complex and tailored to your specific needs. Consider using a battle-tested regex library if available. 3 URL parsing uses erlib.parse in Python and parse_URL in PHP to reliably parse the URL. This is crucial for extracting the host name and other components. 4 whitelist of allowed domains the allowed _domains list specifies the only domains that are permitted. This is the strongest form of protection if you know the valid targets. 5 blacklist of internal IP ranges the IP blacklist contains regular expressions that match internal IP ranges. This prevents requests to loopback addresses, private networks, etc. 6 host name resolution and IP address check the code resolves the host name to an IP address and checks if the IP address is in the blacklist. 7. DNS rebinding mitigation *. The code double checks the IP address after the initial resolution. If the IP address has changed, it indicates a potential DNS rebinding attack and the request is rejected. This is crucial. 8. Timeout *. The requests.get and curl_exec functions have a timeout set. This prevents the server from hanging indefinitely if the target is unresponsive. 9. Error handling *. The code uses try, except blocks to handle potential errors, example requests.exceptions.requestException, socket.getError, and prevent the application from crashing. 10. Sanitized error messages *. The error messages displayed to the user are generic. Detailed error messages are logged internally for debugging. Important considerations and best practices *. Regex complexity *. Writing a perfect regex for URL validation is difficult. Consider using a dedicated URL validation library or a well-tested regex pattern from a reputable source. Regularly review and update your regex to address new bypass techniques. Dynamic whitelisting *. If your application needs to support a dynamic list of allowed domains, implement a mechanism to update the whitelist securely. Protect the whitelist from modification by unauthorized users. DNS caching *. Be aware that DNS results can be cached. The DNS rebinding mitigation relies on re-resolving the host name, but caching could interfere with the effectiveness of this technique. Consider disabling DNS caching for these critical checks or using a shorter TTL, time to live, for DNS records. Server name indication, SNI. When using HTTPS, the client sends the host name of the server it's trying to connect to in the SNI, server name indication, extension of the TLS handshake. This allows the server to present the correct certificate. An attacker might try to bypass validation by providing a valid host name in the SNI but a malicious IP address. Ensure your validation considers the SNI. Defense in depth *. SSRF prevention should be part of a broader security strategy. Implement multiple layers of defense to mitigate the risk. Regularly review and update. Keep your security measures up to date with the latest security best practices and vulnerability information. New bypass techniques are constantly being discovered. Logging and monitoring. Log all outgoing requests and monitor for suspicious activity, such as requests to internal IP addresses or unusual URLs. 6. Testing for SSRF vulnerabilities. Manual testing. Fuzzing. Submit a variety of URLs with different payloads to see how the server responds. Try variations of localhost, internal IP addresses, file protocols, etc. Burp Suite /OWASP-ZAP. Use a web proxy like Burp Suite or OWASP-ZAP to intercept and modify HTTP requests. This allows you to easily experiment with different payloads and observe the server's response. Collaboration with network engineers. If you have access, work with network engineers to monitor network traffic originating from the vulnerable server when testing SSRF payloads. This can help you confirm that the requests are reaching internal services. Automated scanning. OWASP-ZAP. OWASP-ZAP has a built-in active scanner that can detect SSRF vulnerabilities. Burp Suite Professional. Burp Suite Professional scanner includes SSRF detection capabilities. Other security scanners. Many other commercial and open source security scanners can detect SSRF vulnerabilities. Considerations for testing. Ethical hacking. Only test for SSRF vulnerabilities on systems that you own or have explicit permission to test. Unauthorized testing is illegal and unethical. Impact assessment. Before testing, understand the potential impact of your tests. SSRF vulnerabilities can be used to access sensitive data or disrupt services. Take precautions to minimize the risk. Reporting. If you find an SSRF vulnerability, report it to the vendor or owner of the system. Provide detailed information about the vulnerability, including steps to reproduce it and potential impact. 7. Conclusion. SSRF is a serious vulnerability that can have devastating consequences. By understanding the attack vectors and implementing the mitigation strategies outlined in this tutorial, you can significantly reduce the risk of SSRF attacks on your applications. Remember that security is an ongoing process. Continuously monitor your applications for vulnerabilities and update your security measures as needed. Defense in depth, combined with proactive testing and awareness, are the keys to protecting your systems from SSRF and other web security threats.